Local maxima is another potential algorithm that I can attempt. However, I don't think this is going to be the best method for us because you can see significant contrast with these coins compared to the background. By comparison, we have one deep shadow here, one semi-obvious one here, and most of the rest of these are going to be a lot harder to detect. Let's continue with template matching. We're going to try to get this method working to see what we can find from it. We already have our crater sample. Now I need to troubleshoot why this is not working. Let's go back to the source and see how they did their coins. NumPy is imported, PyPlot is imported. We don't need data. Double checking to make sure match template is imported. Match template is imported. I also don't need RGB2 gray anymore. It looks like data did not get used. Image is an array. Examining the documentation for the match template method. And let's see what happens if we redefine the image. First, let me verify that this actually presents a valid image. I think it should though. Is that an empty array? Well, this might not work then. This might be where the error is arising. In attempting to address the individual section here, there seems to be some error. As a result of this, the array is null. Why did that work in template matching then? The type is an array. What's the type for the image? Yep, it's an array. Looking at the values, I wonder if there might be an error here. Let's see, so we have higher, lower, higher, lower, higher, lower, lower, higher. I'm not confident that this is correct, but let's see what happens if I switch the values. You went 16, but again, shape is 0, 0. All right, let's go ahead and actually try this, see what we have when we do it this way. No way. This actually runs? Why? Okay, so it generates an actual array. I don't know if the integer type is going to be an issue. I doubt it. What was the original size on my image? Oh, I need to rerun that. It was overwritten. 4096 by 4096. No way. Okay, that's odd. I mean, it generates an actual value. It's not what we want, but it generates something. I'm going to go recheck those points in GIMP. We're importing tile 16. GIMP 2.1. Well, 2.10. I wonder if there's a new version of GIMP as well. Something for later. Open recent, tile 16. All right, moving this over so you can see what I'm seeing. Origin is at the top. Counting from the top. So 4096 down, 4096 across. This one, 37, 36, 320. Oh, that's why the numbers would be reversed. So let's use this one as a template match. 3765, 741, 3858, 849. First, let's see if this generates anything. It does not. Let's go take a look at this coin image. Template is down here. Looks like they generated the points as being from here to here. Let's try that same method. I'm going to flip these points. Let's take a look at the function. Load an image, file name, returns an array. Okay, so this is a NumPy array. Let's revisit NumPy slicing rules. What if these are on the same... So this is x, y, x, y. I wonder if maybe it's supposed to be x, x, y, y. Let's give that a shot. Nope. Am I indexing outside of valid array levels? These numbers should be fine. Why does it keep freaking out on these? Earth data science, that's a good sign. It's not one-dimensional, it's a two-dimensional array. 2 dimensions. These are specific elements, but yes, okay, range, start row index and row index, start column index and column index. Wasn't that what I was doing on one of these? So they are supposed to be matched, start row, end row. And then it flipped. Oh, that might be what's freaking us out. These are in descending order? Well, no, these are... No, oh yeah, these are in... Okay, that might be why now. Ascending, okay. I think I might be getting somewhere. So yes, matched, but flipped. There we go. Now we're talking. Okay. Okay, now I get it. Thank you. earthdatascience.org. Nice. Okay, so this is invalid. That works. That's not needed. That's not needed. I'm putting this one in, but I had a different one selected earlier. Let's go ahead and do this one. So this value. Okay, let's go ahead and run this block again. Time to try now. No immediate syntax error. That's good. Oh, huh. Wait, why did I make such a... yeah, I don't know what that was originally. That's definitely not the correct one. Let's go for this one now. That's not the template I was looking at, was it? Nope, that's not it. What? Okay, let's do rows first. So 1 to 2. No, wait, rows. Starting index 3759. It's close. 3858. Oh, wait, maybe I flipped these numbers. Let's try that again. There we go. That looks like an actual template. Well, it did match the template. However, it matched it extremely closely and only found one item. I'm going to say that's successful for now because it identified the exact same one. This is the same spot, right? Yeah, that's the same one. It literally identified the exact same spot here. So if I were to copy this out to a whole bunch of spots, it'd find those. But anything that's similar, but not exactly similar, doesn't qualify. So that's not going to cut it. That's the most promising one so far. There's also, I don't know, there's a little bit from Blob, sort of interesting that it was identifying some features, not really well though. Finding holes, the holes look a lot like the craters, so figuring out, so there's the filling holes, there's the holes themselves. There might be some way to sort of count from here. That's a spot that I can try next. I might need to go for a completely different algorithm as well. Unclear. Nonetheless, we got somewhere with templates. That's a start.